Hello. The purpose of this video is to demonstrate how you can use a z-distribution or z-scores in order to calculate probabilities of falling somewhere in a population. So just to review, a z-score is calculated by subtracting x minus the mean over the standard deviation, where once you make a z-distribution has a mean equaling 0 and a standard deviation that equals 1. So when we look, it only gives values above the standard deviations: -1, -2, -3, 1, 2, 3. And it works just like any other normal distribution, where it is symmetric. So if I were to cut it down the middle, the left and the right would be equal. It is asymptotic, meaning the tail is continuing on towards infinity. It is the mean equals the median equals the mode, and the area under the curve totals 100%, or 1.0. So everywhere under the whole curve is 100%. Any given slice of that would indicate probability. So if you were to fall in the bottom half of this curve, that would indicate that you have 50% chance or 50% probability that you're going to fall there. If we look at a z-distribution table, a z-distribution table is usually that is in the textbook is set like this, where you have a distribution. It only gives the distribution only gives positive values above the mean. So it starts right here, and it will give scores for z's above 0. Because of the symmetric component, it assumes that any z-score for values above 0 will be the same for the negatives as well. That means we could just, in our minds, when we're reading negative distributions or negative z-scores, we could flip it over and consider the smaller portion to be down here and this to be the larger portion when we're working with negative z-scores. Now we're going to try an example. In this example, we have a mean of 75, a standard deviation of 10, and our goal here is to find the area between the mean and 85, the area between the mean and 60, and the area below 60. And these are the probabilities that any one person would fall into that area. The first thing you want to do when figuring out the probabilities is put all of your raw scores into z-scores. So the first step is to take the 75, the 85, and the 60 and place them into z-scores. Because 75 is the mean, we know that it's going to equal 0, but let's actually see how that number happens. The mean the x is 75 minus the mean all over a standard deviation of 10. That will get us 0 over 10, which results in the 0 that we were expecting to get. For a z of 85, we're going to subtract x value of 85 minus the mean of 75 and put it all over a standard deviation of 10, which will give us 10 over 10, or a z-score of 1. Finally, we'll do the z-score for 60. 60 minus 75, or the mean, all over standard deviation of 10, gets us a score of -15 all over 5, or all over 10, which results in a z-score of -1.5. So we're going to go ahead and plot those. Before we do that, we need to include our raw scale. So our raw scale, we had a mean of 75 and a standard deviation of 10, so that would bring us to 85, 95, and 105, as well as 65, 55, and 45. Our first job is to label our z-scores that we got. So we had a z of 1.0 equals an x of 85. We already have the mean plotted, and we have separately a z of negative 1.5 for our x equals 60 value. Now our first job was to find the area between the mean and a z-score of 85. So I'm going to slice that up and identify that in black. That's goal number 1. Our goal number 2 was going to be trying to find between the mean, 60 and 85. So that is going to be our purple area. And finally, we're going to use a teal color to get the last one, which is the scores below 60. Now remember, these all have to add up to, the whole area has to add up to 100. So in order to get the black area, we look at a z-distribution. So this is the area of the mean and we get the larger portion for a z-score of 1.0 is what did I get it? 84%. But that includes everything below that z-score is, or that percentage is everything below 85. So this whole area, and we just want the black area. Well, we know everything below the mean equals 50%, so we're going to subtract 50 and get 34% for our area between the mean and 85. For our second area, between 85 and 60, we already have one component. We have everything between the mean and 85. We already know that's 34%. So, I'm going to take the 34%, and then on top of that 34%, I have to find this area. Well, the way I can do that is to subtract out this smaller area by using the smaller portion if I flipped my z-table. So if I flipped my z-table and looked at a z-score of negative 1.5, this area, this lower area, would be considered 7%. We know that this area is 34%. We know that this has to be 16% because 34 plus 16 gives us 50. And this area has to be the remaining amount. So that would give us, 43%. So if I add that 43% to that 34 at my total, I'm going to have 77% as my area between a z-score of negative 1 or an x-score of 60 and a z-score of 1 or an x-score of 85. Finally, we've already found out the last part, the area that's less than 60. That's just this remaining this smaller portion on this curve. That would be the 7%. And so each of those are different ways to approach adding up and slicing your distribution that totals 100% into a whole bunch of different areas and finding any one of the slices of the pie. I hope you find this example helpful as you complete your assignment number 2.